Hello there, guys, and welcome to our next class for the fourth unit. Just like you know, this is a class that is part of Beehive School and 7th grade. Our subject is science, and we are working on week number 30 today. So let's start with our presentation, and of course, let's go with our end in mind. Students will be able to imagine the consequences of a volcanic eruption in Quetzaltenango. Alright, so today we have a very interesting topic for us, and here we have a summary of the activities that you need to complete. So, number one, make a timeline of events that will happen in Quetzaltenango if there is a volcanic eruption. So, observation, there was already a volcanic eruption in Quetzaltenango many years ago. I think it was in the 1900s, around 1905, I guess, was the date where the Santa Maria volcano already exploded. So basically, I suggest that you do some research on what happened back then. What happened when the Santa Maria volcano erupted. And of course, based on that information, you can imagine what is going to happen right now if we will get a volcanic eruption at some point. Okay, and number two, you need to complete the book exercises from pages 143 to 145. Then, number three, create a compilation of your work in one document, either Word or PDF, and upload it to Educativa. So, two things to upload to Educativa today. So, of course, the timeline of events, and you need to upload the pictures of the book exercises. All right, so, and by the way, experiment alert next week. So, next week we are going to do an experiment. So, make sure to watch the video. And of course, you can gather the materials for next week. If at any time you have any inconvenience at bringing the materials for the experiment, you can let me know. But that is until next week, okay? And anything else that I need to add with that? Oh, yes. In your unit program, you have a YouTube video to the experiment. So you can click on that link to, of course, watch the video and find out more information about what we are going to do. So let's continue. And of course, we are going to have a little image of what a timeline looks like. So, of course, this is a timeline about social media, in which in 2004, Facebook appeared, as well as in YouTube in 2005. It started gaining more fame. Twitter appeared in 2006. And so on and so forth. It continues over and over. So basically, you have to do something like this. But instead of social media, of course, you are going to include the events that will actually happen if a volcanic eruption will happen in Quetzaltenango. And here you have a picture of the rubric that I am going to use in order to evaluate your timelines. So if you have any questions about it, you can let me know, of course. Okay, so let's start with our topic, and we're just continuing the topic from last week. And this time we are covering pages 143 to 145. And we're going to start by talking about volcano hazards. And what is that exactly, and how is it related to this terrifying image that you have on your left? You can notice like a big cloud of fog and different volcanic components that are coming right behind this little band that is trying to run away from it. So both quiet and loud eruptions can cause damage. But of course, the damage that they are going to cause are quite different. And quiet eruptions, lava flows out of several vents and the volcano's crater. It burns everything in its path and covers a large area with a thick layer of lava. So just like we analyzed before, in quiet eruptions, and of course talking about lava, it is going to easily flow out of the vents and of the volcano. But it doesn't mean that it is not going to damage anything. So remember that lava is extremely hot, so it can burn many things around the volcano, and of course cover it with a thick layer of this component. On the other hand, we have explosive eruptions. During an explosive eruption, a mixture of dangerous materials, such as hot rock and ash, are released, which generates a pyroclastic flow. what is that word specifically? What is a pyroclastic flow? It is a dense cloud of hot gases, ash, cinders, and bombs that flow down the sides of the volcano. And right over here on the left, you have the representation of what a pyroclastic flow actually looks like. So, of course, that is why it is necessary to recommend people that live close to volcanoes to actually go away as far as possible from the volcano, so they are not going to be affected by the lava, as in the case of the quiet eruptions, or by all of the materials that are released during an explosive eruption, and of course the pyroclastic flow. Alright, so now we're going to talk about the stages of the volcanic activity. And first of all, we have an active volcano. What does it mean when we say that there is an active volcano? Basically, it shows constant activity or signals that will suddenly erupt. So basically, this activity means that lava is constantly popping out of different vents or popping out of the crater of the volcano. So that's the way we can identify an active volcano. We also have a dormant volcano. It is an inactive volcano that scientists expect to wake up in the future. It can be known as a sleeping volcano. So basically, in dormant volcanoes, there is a probability that they are going to be active in the future. But right now, they have little or none activity at all. And also we have an extinct volcano. They are known as dead volcanoes as well. It is more likely that they will never erupt again, since they have moved from the hot spot. So remember that in every volcano, necessarily we need a magma chamber, and of course we need that it is connected to a big body of lava. And what happens if actually the volcano is not connected anymore to a lava chamber or to one of those chains that are going to be actually providing the volcano with more material? We're going to define it as an extinct volcano, because no matter what happens, they are not going to be active anymore. All right, and here we have an example of a volcano, of the volcano fire. And the volcano fire is actually located in Guatemala. And it is constantly active. That's why we say it is going to be an active volcano. So from a couple of years ago from now, it is always erupting. It is constantly actually releasing lava from its crater. And of course, it has caused many damage in several locations around Guatemala. And I actually went hiking once to the volcano fire in Guatemala. And it was a very nice experience. Unfortunately, I couldn't actually see lava from the place that we went to because the volcano wasn't that active. But with the pass of time, it has become more and more active. Here we have another example of a volcano, and it is the Santa Maria volcano, and we can call it a dormant volcano. And why is that? Because the Santa Maria volcano has little to none activity. So probably there is not a lot of activity right now, but in the future it can become active again. All right, and now we are going to talk about monitoring volcanoes. How do scientists monitor volcanoes? So they are going to use several instruments, and one of them can be the tilt meters. And they can detect slight changes on the ground caused by lava. So if a lot of lava is moving right on the ground, right under the ground, then it can cause variations in the ground. Probably it can go a little bit higher or it can be a little bit lower. So thanks to this instrument, scientists can measure those very little variations and of course identify if there is a lot of magma activity underground. Geologists can also study the gases that come out of the volcanoes. So remember that we studied that there are plenty of gases immersed inside the magma of a volcano. And during an eruption, of course, all of those gases are going to produce several bubbles, and they are going to be released in an explosion in some cases. So those gases can actually help scientists to analyze if the volcano might erupt in a close future. Geologists can study small earthquakes that can lead to the eruption of a volcano. So definitely, remember that when an earthquake takes place, it is going to cause several vibrations around the epicenter and of course in several places that might be close to the focus point of the earthquake. So what happens is that if the earthquake has a very high magnitude, then it is going to generate a gigantic, let's say, change of energy inside the volcano, or a gigantic change in general. So basically, when it moves a lot, then it is going to influence in an eruption to happen. So that is very important to take into consideration. And the increase in temperature from underground can mean that magma is rising. Of course, if magma is closer to the ground, of course, we are going to have way higher temperatures. All right, guys, and that'll be about it for today's presentation. Thank you a lot for coming, and remember to go back to the activities section to notice what you have to complete today. It's been a pleasure seeing you all around, so I will see you in a couple of minutes during our Zoom session. Goodbye, everyone, and always take care.